Hello, ladies and gentlemen. Welcome back to Chapter 12. We are on Part 3, talking about chemical solutions. Okay, we have been talking about things dissolving, but the question is, why do some things dissolve but not others? You can put something and it'll dissolve in one substance, but it won't dissolve in something else. So the question is why does that happen? Okay, when we're talking about this, what we're talking about is solubility, which is related to how well something dissolves. And it's measured by looking at the maximum amount of a solute that can dissolve in a specific solvent. Now remember, the solute is what is getting dissolved. The solvent is what's doing the dissolving, although in the cases of gases or things like that, remember, solvent is defined as whichever there's a larger amount of. Okay? So when we're talking about solubility, there's a number of different things that are involved, and we're only going to go over some of them today. But primarily, we're going to go over the most important, which is a phrase that no matter what chemistry class you go to, you will hear, which is like dissolves like. Now, what that means is things that are alike will be dissolved in that type of substance. For example, polar solvents like water, remember it has a slight charge, dissolve polar solutes. So that includes things like sugar, which is covalent, but it also would include things like salt, which are ionic. Both of them have slight charges, and that causes the water to be able to pull them apart and dissolve them. Also, in the same way that polar solvents can dissolve polar solutes, nonpolar solvents can dissolve nonpolar solutes. And what you're seeing here is where they aren't dissolving. You have the oil of some sort combined with the water, and it simply prevents them from dissolving because the difference in their chemical structure. Okay? Okay. This is a video that talks about how like dissolves like. You can see that right in the name. Told you it's everywhere. These are the ingredients that are going to be used. The experiment was on the long side. She talked a lot about things we don't really need to know. Just realize the two solvents are water and what are referred to as hexanes. Hexanes are nonpolar. And then you have copper chloride and iodine as the solutes, the things getting dissolved. Now, she speaks pretty quietly, so I am going to put the captions on.
This demonstration is being done in a fume hood because it's not very wise to breathe in hexane vapors. Approximately 15 milliliters of water were poured into the first 3 test tubes, and approximately 15 milliliters of hexane were poured into the last 3 test tubes. Notice that the polar water and the non-polar hexane form layers. They are immiscible, meaning that they are liquids that do not dissolve in each other. The density of water is 1 gram per mil, but the density of hexane is only 0.66 grams per mil, so the hexane floats on the water. Iodine is added to the hexane. Notice it begins to dissolve immediately. Iodine is then added to the water, but nothing happens even when it is stirred. Next, copper 2 chloride is added first to the hexane and then to the water. At the top of the hexane liquid, you'll see a reflection of the copper 2 chloride sitting at the bottom, but the copper 2 chloride does not dissolve in the hexane, even with stirring. The copper 2 chloride does, however, dissolve in the water. Just for fun and to show once again that the polar and nonpolar substances don't like to mix, both iodine and copper 2 chloride were added to the middle test tube. The iodine was a little difficult to mix simply because it is more dense than both hexane and water and kept falling to the bottom of the test tube. But as you can see, water, as the polar solvent, dissolved the copper 2 chloride, an ionic compound, but not the iodine, a nonpolar molecule. And hexane, as the nonpolar solvent, dissolved the iodine, but not the copper 2 chloride.
Okay, so what you saw, if we go back a little bit, you have the hexane dissolving the iodine, but not the copper chloride. You can see that on top right here. And you have the water that is not able to dissolve the iodine, but does dissolve the copper chloride. And the hexane floats over the water, so you can see the reality that the substances are separated. Okay? It is interesting to play with different things like this. Let's see.
Dissolve the iodine.
Okay, let's get rid of her. Okay.
But not.
Okay, when we talk about solubility, it is also related to the amount of solute able to dissolve in it. Now, if you have what is considered an unsaturated solution, which means that you are able to put more of the solute in, so you're just putting a little bit in. This is referred to as unsaturated. It's not full. Think saturated as, you think of a saturated sponge. It's able to, it's full of water. So this is unsaturated. You can dissolve more solute than is possible, than is already dissolved there. Okay? If something is saturated, what that means, it is full. Now, usually what you would see, or if you could see it, is that at the same time that some of the solute is dissolving, some of it is recrystallizing. Okay? And you have more than can completely dissolve. And this balance, if you will, of some dissolving and some recrystallizing over and over again is called dynamic equilibrium. Dynamic meaning it's still moving, it's changing, but at the same time it's staying the same overall. Okay? Now, a saturated solution, the reality means that you can't dissolve any more solute in it. There's no room for the solute particles mixed into the solvent. So usually, but not always, depending how careful you are, you will see undissolved solute at the bottom of the container. Only so much sugar can mix into the tea, for example. Okay, so you can only make it so sweet. The other sugar, or whatever the solute is, will sit on the bottom. Okay, now this is something called supersaturation. And if you look at the top left, supersaturation, it only happens intentionally by a process, except perhaps in deserts or something like that. Basically, you take a regular solution and you saturate it. Okay, so you dissolve, say, all the sugar you can dissolve in the water. Then you heat it up. Now, as you probably know, you can dissolve more sugar in something that is hot than something that is cold. So what you can do then is you can increase the amount of solute that's dissolved when it's hot. And what you then do is you bring it back down to room temperature, but you don't add any solute or solvent, and you just let it sit. And basically you have more solute dissolved than should be able at room temperature. Some things are very precarious, and the solute will instantly come out of solution if certain things are done. What the video is that you're going to see is of one that is actually relatively stable, which is a supersaturated sodium acetate solution. And from what I've heard, it's really fun to do, and it can be done over and over again using the same solution. So have a look.
Okay. See one little crystal.
Zoom in, Rena.
I don't know how.
Go closer.
Hold on.
Just start.
You can't even see it.
Okay, go.
You can hardly see. It's
Okay,
right
well,
at the-
there's a crystal
it's
on
right-
You might crystallize your
It's not gonna crystallize on me.
on your phone.
Ready?
Yes.
So realize this has been sitting there all year long like this. Okay.
What is it?
I'm
What
gonna
is it?
change. Huh? Well, it's water that has a huge amount of these crystals dissolved in it.
Oh.
It has so much of it that is called supersaturated. It actually is holding more salt than water actually can.
How does that work?
Because I boiled it.
You dropped it in there?
What?
Oh snap!
Oh my gosh, that's so cool!
It looks like a sea
It looks like
urchin.
a looks like a
Looks
puff
like a sea
ball.
urchin.
My finger ran out of. Oh my god.
Oh my god.
That's so cool.
It's so
What happened to the bug?
What happens if you? It's still over there.
That's so
Ow!
cool.
It's still
That was
right,
just one drop.
right there.
One crystal.
Imagine
Look at it
more
extending from the bottom.
Oh, that one's racing. It's racing. Look, that one's Jeremy. He got it. He
Yeah, I get there first.
Watch it race.
Want to see my nail? I want my nail to be in the picture.
Oh my gosh, Elijah, this is giving me goosebumps.
It does look kind of weird.
This is so cool. Is this real? They look like feathers.
Can we touch it?
Oh my god.
Are we gonna
Well,
blow it?
wait till it's all crystallized.
You would touch it either way, but
I
I
would.
touch radioactive things. Oh my gosh, poor Austin.
You can't see like that.
He's in
Rena, stop.
Korea.
He's having more fun.
Are you gonna break it off and give pieces to all of us?
Could we
Can
blow
that
it if we
happen?
touched it?
Huh? Well, first touch the sides.
Is it cold?
I should have had you touch the
It's probably
sides
freezing, right?
before. No,
It's
No?
warm. It's it's not even like frozen.
It's not
it's
cold.
not only not cold, it's warm.
Yeah.
It warmed up. So the crystallization process actually releases heat.
Just gross stuff in
Why
here.
would you
Gross stuff in here.
Can we really touch it?
Huh?
Like with our hand
can we
burn?
Yeah,
touch
go
it.
ahead and touch the top now.
Oh, are you sure we can't?
Don't
Is
do
it
it. You're
liquid
gonna
or
get hurt.
solid?
Why are you mushing it? I want to touch.
Oh, that's so cool.
It's
Isn't it?
it's very
So now you have to
Elijah!
Here, Jerry, you want to touch it?
What the hell?
It's
Why is
like
it warm?
I want
warm.
to see.
Exothermic.
Miss S, come look at this. We just saw it.
We just did an experiment. We just watched it
It
crystallize.
made into crystal.
Out of all year, now you guys do an experiment?
We did do it.
It's because no one is here.
Touch it. Touch it.
That's okay.
It's
Okay, and if you're wondering why that's a practical thing, that is what is done for making those hot packs that you probably don't use too often in Florida, but some of you may have used them if you go up north in the wintertime, where you kind of pop something inside and the pack gets warm. That is actually a supersaturated sodium acetate solution. So this is not just theoretical, this is how you warm your hands in the 10-degree weather if you have to stay outside. Okay, we will talk more about solubility and about how things are affected by, or I should say how solutions are affected by other things. Until next time.